Okay, can you hear something now?
Right. We can't even log on to the thing.
Because it shows now that I have sound.
I'll give it about a minute with the lag, and then we'll see if it says
Okay.
yes sound.
Yes, sound.
Yes, you have your report says sound. Okay.
All right.
Okay.
Okay, good.
So Alex, what is the license on the Machinetalk stuff?
Well, I think you're going to get to that.
Well,
Start from slide one. Now that
Yes,
we
let's
can
start
hear you.
from
Okay.
slide 1.
Okay, we're rewind and play.
Okay,
Keep it close so that you.
so yeah, it says that the volume is quite good now. So okay, sorry for the technical problems, and let's start over. Welcome to the Machinetalk Meetup 2015. I will start with a talk about the Python Machinetalk bindings, which will be about the Machinetalk API itself, the Python Machinetalk bindings, some possible applications for the Python Machinetalk, and outlook for the future, what could be implemented, what should be implemented, and so on. Machinetalk is a middleware for MachineKit. It can be used as a way to communicate between non-RT and RT applications. It can be used to create distributed setups for machines to communicate with each other, for user interfaces to communicate with machines, and in general, machines talking to each other. And Machinetalk is also important because it can act as license abstraction between the GPL license MachineKit software and possible user interfaces, third-party plugins, and so on. The license depends on the bindings, binding implementation. Machinetalk is licensed under the MIT license. The other bindings are created. Quick VCP is LGPL. And I think Bob will tell us what Node.js is licensed in. Yeah, Machinetalk is organized in so-called services, meaning small applications providing a certain service. And I will go now into the details about the separate services, and not so much into the details about like the communication and so on. So if you're interested in this topic, I've given a talk like 6 months ago, I think, on the Vienna Internet of Things monthly meetup. So if you're interested more in the technical details, you may take a look at this. This is more the things that are important for using Python Machinetalk and other bindings. So we have the launcher service, which is implemented by mklauncher. It actually uses two services. One, the launcher service itself, which is uses the publish subscribe network pattern, and launcher command, which uses root the dealer pattern. It is meant to be the first contact point for a possible user interface or like a client. So it can start MachineKit instances, can start software. So it is kind of like the Linux CNC launcher dialog where you can select the configuration, but the remote version of it. So it will supply a list of configurations to the client, launches new instances, and reports running instances. Then we have the config service, which is, the whole idea behind this service is remotely distributing user interfaces. Could also be used not only for QML user interfaces, also for GTK or all other kind of source-based user interfaces. It may be maybe not so useful for binary distribution because we have different kind of clients, but it works very well for, let's say, QML or maybe also GTK. Besides just deploying configurations, it also shows currently running configurations and can be used for a client to detect whether an instance is running or not. I will go to in detail on the typical flow of connecting afterwards. Then we have the HALREMOTE service, which is kind of the core of Machinetalk at the moment. It has two services, the HALRCOM service and the HALRCommand service. The HALRCOM service can be used, is used to use a publish subscribe pattern and publishes pin changes, updates to a HAL configuration and so on. It is used in combination with the HALRCommand service, where you can say bind to this HALREMOTE component, and then you will get a full update over the HALRCOM service. And in case something changes, you get incremental updates. So this is a very important design detail compared to the current or the previous local HAL implementations, where you have to like poll all the time for pin changes and so on. So you will get, thanks to the publish subscribe pattern, you will get notified when a pin changes. It is implemented by HALTalk, which is written in C and talks directly to the HAL instance itself. And it is kind of the core remote API for HAL and Machinetalk. So to explain this picture, a common use case for this is having a HAL instance running on a Linux machine. The HAL instance lives in the RT environment. However, the HALREMOTE instance is non-RT, so it talks to HALTalk and the user interface, but you cannot expect like a certain timed behavior of it. It's like a userland component, not an RT, of course. So it talks over HALTalk to, for example, a user interface. This can also be like a third-party plugin. It could be anything you implement with a HALTalk binding, basically. Common use case is like some sliders or knobs in a user interface to change values inside HAL. Then we have the so-called application services. This is basically what you know about as the typical CNC application. It is implemented by mkwrapper, which is a wrapper around the Python Linux CNC module, and it uses all the EMC status classes and so on to communicate with the client. So there are a few services. There's the status service, which uses a publish subscribe pattern. It outputs things like the current motion status, currently task status, and so on. There's the command service, which is like Linux CNC.command Python. It basically sends commands to the directly to mkwrapper, which issues the Python Linux CNC command service module functions. Then there's the error service, which is used for reporting errors to clients. A very important fact for the error service, the normal Python Linux CNC error module deploys the errors only to one client, whereas this service deploys it to all clients. So it uses also a publish subscribe pattern. So if you have multiple clients connected, all we get the error message, not only the first who polls it, basically. So this is a very important design difference. Then we have the file service, which is new to Machinetalk because since you cannot expect that the implementation is running on the same computer as the MachineKit instance, you need a way to deploy files. So the file service, basically, it is an FTP server, which is announced on the network, which the client can use to see what's on the MachineKit computer and to deploy files, to download files, and so on. Yeah, the preview service is kind of new because it's like a remote interface for an interpreter. So currently the preview interface parses an G-code file and outputs commands like arg2, whatever, line2, and so on. So it can be used for a client to like display a preview for G-code. But in the future, it may be something like a generic interpreter interface so you can also use whatever interpreter to either preview something, to run something, or to test something. Yeah, it's very new, and preview is only a temporary implementation for the preview. For the preview for user interfaces. Yeah, of course, if we have services, we need a way to find them on the network. Can imagine it doesn't only work locally, so like a text file or a static configuration would not make sense in most cases. Let's imagine we have like a tablet that wants to connect to a like a BeagleBone connected to a network. So using a text file or a static configuration would not work out very well. This is the reason we implemented a service discovery mechanism. We used multicast DNS, DNSSD, which is also known as ZeroConf or Bonjour by Apple. So it is widely used for example, for like network printers, like your iPod probably announces itself on the network. Like, it's widely used in general. In Linux, it uses the .local domain, so your domain name discovery also works with this. So if you have a Linux computer, it already works in the background. That is very good because we do not have a lot of dependencies on the Linux machines itself, and it works very well. And yeah, it's like some kind of it's almost native to Linux. Yeah, it works as auto configuration mechanism. It works completely decentralized. We do not need like a server instance that knows about all services. So you can also add like a webcam service to another device. And another nice thing is it works with multicast, but also with normal unicast DNS. So you can specify like an IP address, send the request to this IP address, and you will get back normal DNS requests, responses. And so it works also in the case you have, you will want, for example, to go through a firewall or something like that. Multicast does only work on the current subnet, so it only works if you're in the same subnet, not in a different net. So unicast works for these cases. Or if you have like a local instance, unicast may be also preferable. Yeah, how does a typical connection work? Let's say we have like a user interface that wants to use Machinetalk. First, we search for launcher instances on a network. Typically, we have like either we have a single Machinetalk enabled device running on the network, or we have multiple devices. So we first look for launcher instances on these devices. Then we list them in the user interface. So we get a list of possible endpoints. And once we have found the instance we want, the services announce names and UUIDs and other meta information. We filter the services, and first we have to select a service, and then we use the UUID to filter all the instances, all the services we get. So in the end, we have like a list of services that are already filtered by a UUID, and UUID relates to the machine kit instance. In case this is a user interface, we will also start looking for a config service where we can deploy, we can get a remotely deployed user interface. Then we load the user interface, of course. And once this is done, we connect to the other services from the list. Yeah, this is how a typical connection flow works. Quickly take a look at the time. It's already 10 a.m. So question is?
Should I announce on the list that we're running a little bit late with this talk, that we will just finish it? Or?
Yeah.
And I'll keep the list a little bit updated on the stuff because we started a little bit late.
Yeah, can you delay the? I think it's yeah, probably best. I mean, it will be done in 5 minutes. I will wrap it up.
Yeah.
And then we can go ahead with Paul. Okay. So quickly to Python Machinetalk itself. It uses Python threading, so it works mostly asynchronous, meaning that it's not like a typical application Python workflow where you can, let's say, create component, set pin, and so on. So you have to keep in mind that it's completely asynchronous, of course, since we cannot expect that the instance is already connected and so on. However, Python threading offers some methods for synchronous update and notification and so on. So we can wait for the threads and for an update on the network, which is very useful when we want to create like a test for Machinetalk itself. So we use logs and conditions to achieve that. And so you have choice either to use asynchronous or asynchronous or almost synchronous behavior. We have three services, three Python modules. One is DNSSD, which implements the service discovery. It uses Python Avahi and dbus to communicate with the Linux Avahi daemon. Yeah, so much to that. Python dbus currently requires G-object threads. So this is a little bit of a limitation because you always have to need a G-object main loop running in the background. It works, but currently the synchronous behaviors, like if you want to make a test, is not 100% deterministic. Asynchronously, it works perfectly. So there may need to be like there's room for improvement in this module, basically. You can use a typical service type looks like that. It's that's how multicast DNS service type name looks like. So we have the service, like launcher in this case. Then we have a main domain like the machine kit, and we have TCP. In most cases, we have TCP, even if we don't use TCP for the actual service. It's kind of like a standard. Most services that are announced on the network announce that they're TCP, even if they're not. So, yeah, this is kind of the standard service string we use. And DNSSD uses callbacks. So if your service is announced on the network and you get a callback that this service has been found. Then we have HALREMOTE, which is, it's canonical to the HAL userland components. It has exactly the same interface, works exactly the same, but the difference is that it's not local. So you cannot expect that a pin change instantly changes something in the remote HAL configuration. Yeah, we have the remote component and the pin, which is exactly the same as the HAL Python bindings, basically. We'll give a quick example later on. And we have application, which is what we want for a typical CNC user interface: status, command, arrow, and file. So there's currently no implementation for launcher and no implementation for the config service. Currently, it expects that you specify the UID manually. There's no standard way of using launcher at the moment. This is one of the things that needs to be implemented, but it works very well for local interfaces, or if you implement a selection dialog or something yourself. Typical applications. First, we can test Machinetalk, which is a general improvement, so we can actually test that everything works correctly and correct HALDoc and Collage and so on. Then we can create something like a remote interface to HAL. Let's say, for example, you have an additional device that where you have something like a button or something like that, and you want to connect it to a remote machine kit instance. You can use Machinetalk for that. You can create like command line interfaces. You can create user interfaces, or we can even create like two HAL instances talking to each other. Would also be possible. And very importantly, we can use it as API for third-party plugins. So a little bit of outlook in the future. What needs to be implemented is the launch and config service. There needs to I need to work on the documentation. So it's currently, in general, the Machinetalk API is not very well documented. Also because it's still under development, and not everything is like some things like especially in the typical CNC and application services, things are a little bit changing since it's all pretty new, and yeah, so the API is not finished at the moment. But I'm working on the documentation. I've already created a pull request for the Machinetalk protobuf bindings, so yeah, this will come. And yeah, more examples in general. Unit tests for Machinetalk, also very important, integrated with the machine kit testing system. And yeah, of course, whatever you can imagine doing with Python and yeah, Machinetalk. Yeah, for more information, visit the GitHub repository and yeah, the Machinetalk kit website and so on. Okay, thank you very much. Are there any questions? I think we should keep it short because of the next talk coming up.
So the package requirements for a remote entity to talk to HAL would be Hawaii, G-Object, Beatles, the protobuf stack, 0Q, and that's pretty much it, I think.
Yes, so the problem is here, not on the microphone, but yes, so to wrap it up, basically, Michael asked what is needed for the Machinetalk to work on a Linux computer. It's Python Hawaii, Python dbus, the Machinetalk protobuf, Python G-Object, and 0Q, of course. Yeah, and yeah, the protobuf, which is included in the Machinetalk protobuf. Yeah, that's it. Yeah, it's handled on 0Q, and it can work for both. Yeah, I would like to give some code examples, but I think we should go ahead with the next talk.
But yeah, we about half a year or so we did all the extensions to do it IPv6, IPv4, and then in preference there.
Okay, was there a previous on that?
Yeah.
Should work. Okay. The slides are going to be available afterwards.
Yes. Yeah. Okay.
My laptop is ready for you, but I don't have any clue about technical